So hello everyone, welcome to my YouTube channel. It's me Apurv Gaurav, library ID 23IS2065, subject name Applied Physics, subject code BPHY103. So let's begin with the introduction of this topic, physics of animation. Physical animation is a dynamic discipline blending physics and computer graphics to simulate realistic movements in virtual environments. Utilizing mathematical models, physical animation replicates natural forces such as gravity and friction to create lifelike motion in digital simulation. This interdisciplinary field enhances visual realism in animation and simulation, fostering application in gaming, film, and virtual reality. The history of physics in an animation traces back to the early 20th century when animators began incorporating principles of physics like gravity and motion to create more realistic and dynamic movements. Advancements in technology have since propelled physics animation, revolutionizing industries like film and gaming with lifelike simulation, showcasing the synergy between science and art in every evolving world of animation. Principle of animation. Principle of animation encompass fundamental guidelines developed by Disney animators Frank Thomas and Ollie Johnston. These principles include concepts like squash and stretch, anticipation, and timing. They serve as a framework for creating captivating and realistic motion in animated sequences, influencing the visual appeal and storytelling aspects of animated content across various media. Motion and kinematics. Motion refers to the change in position of an object over time. Kinematics, a branch of physics, especially studies motion, focusing on the description of spatial and temporal aspects without considering the forces causing it. It quantifies parameters like velocity and acceleration to analyze the understand the dynamics of moving objects. Force and dynamics. Forces are interactions that cause object to accelerate or deform. Dynamic, a branch of physics, explored the effect of forces on motion. It involves analyzing how force influence the velocity, acceleration, and equilibrium of objects, providing insights into the behavior of systems under the influence of external influences. Fluid dynamics and simulation. Fluid dynamics is the study of fluid, liquid, and gas in motion, examining their behavior and interactions. Simulation in this context involves using computational methods to model and predict fluid flow. It is widely applied in engineering and animation to replicate realistic fluid behaviors such as water movement in visual effects. Light and optics. Light is electromagnetic radiation that our eyes perceive. Optics is the study of light and its interaction with matter. This branch of physics explores phenomena like reflection, refracting, and diffraction, providing insights into the behavior and properties of light. Character rigging and physics. Character rigging is the process of creating a digital skeleton rig for animating characters. Physics in animation involves simulating realistic movements using mathematical models. Together, they enable lifelike characters animation by incorporating dynamic physics principles into the rigged structures for natural motion portrayal. Emerging technologies in animation. Emerging technologies in animation involve innovative tools and methods that push the boundaries of traditional animation. This includes real-time rendering, virtual reality, augmented reality, machine learning, and AI-driven techniques, contributing to more immersive and dynamic storytelling experiences in the animation industry. Challenges and innovation. Challenges in the physics of animation include simulating complex physical interaction realistically. Innovation address these hurdles through advanced algorithm and computing power, enabling more accurate representation of natural phenomena, pushing the boundaries of visual fidelity and immersion in animated content. Future of animation. The future of animation in terms of physics involves continued integration of cutting edge technologies like real time physics simulation, AI-driven character interaction, and enhanced rendering capabilities. This promises more realistic and immersive animation, pushing the boundaries of storytelling and virtual experiences. So, the conclusion of this topic. In conclusion, the physics of animation is a dynamic field that continually evolves through the integration of advanced technologies. As computational power and algorithm progress, the synthesis of realistic physics in animation will further enhance visual storytelling, virtual experiences, and the overall quality of animated content.